maybe if there's something you'd like to see in the future, you could write it down. And at the end, there's a little gold box next to the food table in the back, so afterward you could help yourself with some snacks and juice and coffee and turn in the evaluation forms and the pencils. So that's it. So Griselda, I'm Julia, sorry. I'm one of the co-directors of Science in the News, and we are sort of a part of an organization called Science and Engineers for America, the Yale Student Chapter, and Griselda is the other co-chair, so she'll tell you how.
So I'm Griselda, I'm also a grad student here at Yale, and I have the pleasure of introducing our speakers, which Rakina, Heather, and Will, and they are grad students and postdocs from the Yale Immunobiology program. And so they do research in studying the cells in your immune system that help protect you against disease. And today they're going to talk to you a little bit about like what those cells are and how vaccines help your cells protect you against disease, and also talk about some things you may have heard of in the news regarding vaccines, and controversies, and then like the future of vaccines. So let's get started.
Okay, hi everyone. I'm Rakina, so I'll talk about briefly about history of vaccination, the main types of vaccines, and the immune response against vaccine. So, as we talk about vaccines, let's first tell where they got their name from. Vacca in Latin means cow, and there's a very interesting story behind. Like the main character is this gentleman here called Edward Jenner, who was a physician in England around 200 years ago. So that's during this time, the smallpox was a huge problem. It killed almost 10% of the population, starting from queens, kings, emperors, and reaching down to the common man. And if it didn't kill you, your skin was left scarred by the pox. And some believe that because of this, this trend came to ladies to have beauty spots or veils so they can hide their blemishes. And the only people which were protected kind of from the smallpox were the milkmaids. So if you look back in this time, you'll see a lot of poems and songs about the beautiful milkmaids, and actually the reason was that they had very beautiful skin, smooth complexion, because it turned out that during their work with the cows, sometimes they acquired cowpox, and this seemed to protect them from subsequent exposure to smallpox. The cowpox actually is a mild viral infection in cows caused by vaccinia virus. And these milkmaids will occasionally catch the cowpox, but the disease wouldn't trouble them. Mostly they'll develop some pox on their hands, and that's all. Where the smallpox is caused by variola virus, and it's a really dangerous infectious disease, and most of the time, people just die. So Jenner was very interested, is it true that if you have the cowpox, if you catch it from the cows, then you'll be protected from the smallpox? So the story tells, this is actually his article based on this study he published, a very famous article. The story tells that one milkmaid came, her name was Sarah, and she wanted to ask him about some rash on her hand, and then he actually diagnosed cowpox. And then he realized this is actually his chance to test if you have a cowpox, then they will be protected from the smallpox. And this is what this picture here shows. He chose a small boy, which was named James. It was the son of his gardener. So what he did is he made a few scratches on James' arm and inoculated some material of this pox from the hand of the milkmaid. And then, with great relief and enthusiasm, he really found that after that the boy was protected from the smallpox. And that's how actually the modern vaccination was the first attempt for vaccination. But before I tell you a little bit more how the vaccine works, let's talk about the main types of vaccines. So the goal of each vaccine is actually to use a weakened, harmless form of a pathogen which normally will cause disease. So you have an immune response, but without having the symptoms of the disease. So for example, these triangles here are some component which might cause a disease. And let's say we have these three types: live attenuated, inactivated, and subunit vaccines. What does it mean, live attenuated? You have, for example, virus, which is weakened in a lab, and in this way is made very harmless, but still induces a very strong immune response. And this is, for example, the famous MMR vaccines is from this type. So in very rare cases, this might cause an infection, but this is the most effective type of vaccines. The other two vaccines, inactivated or killed and subunit vaccines that cannot cause disease. The inactivated, the virus or bacteria is completely inactivated, is killed using some heat or chemical. So it cannot cause disease, but still can induce immune response. And these are vaccines, influenza vaccine, or famously known as flu, inactivated polio, or hepatitis A. But this vaccine wouldn't make a strong immune response, so that's why you should go normally to have a booster, or you should have several doses of this vaccine. And the third one, the subunit vaccine, actually you don't have the whole microbe, you just take a part of it, which will elicit the strongest immune response, and you just use it for a vaccine. This might be part of a virus, as in a hepatitis B vaccine, or part of a bacteria. Basically, bacteria secrete some toxic products which can harm your cell. They are called toxins. When they are inactivated, they are called toxic. And for example, the pertussis vaccine is from this type. So let me tell you also about some of the most important cells of the immune system which protects you against disease. These are B and T cells. So the B cell actually recognize microbes outside cell, microbes and their products which just are freely circulating in the body fluids. So what they do is when they recognize the microbe, they start to multiply, forming a huge army of identical cells, and then they produce these proteins called antibodies. And the antibody will stick to the bacteria and will just prevent from causing some disease or infection. So basically, it just prevents it from entering the cell. And this might be not only the bacteria, but the toxic product which the bacteria secretes, the toxins. So it just cannot enter cell and cannot cause disease. And this process actually is called neutralization. And we'll talk also about this later in so-called mucosal immunity, where it has a really large role, plays a really important role. So besides preventing microbes from entering the cell through this neutralization process, antibodies also mark microbes for destruction from other cells of the immune systems. So these are the main important functions of the antibodies. Antibodies, however, cannot see microbes which are hiding inside the cells, and for this we use another type of cell of the immune system called T cells, which can recognize infected cells which have microbes like viruses, which are inside the cell. And what they will do, again, they'll form a huge army of identical cells, which all together will directly kill the infected cell, and in this way will just stop spread of infection, kill the reservoir of an infection. So during this process, also very importantly, some of these cells will become memories, what we call the memory being or T cells. So basically what does it mean is that they will remember this microbe, and next time when it comes, they will elicit very strong response against. And that's actually is the very basic of vaccines. They use this property of the immune system that it can remember microbes once they were exposed to it. So next time when they see the same microbe, the response is very strong and very efficient. So that's how, for example, some type of vaccine works. I will just show you an example. You have a vaccine with, let's say, killed or weakened microbe, bacteria, or a virus. the B cell will recognize it, and then they will produce this huge army of identical cells which will go ahead and prevent this microbe from causing harm to the cell. And during this process also will form some memory cells which will remember this microbe. So now what happens is when you get a real microbe or viral infection, for example, you already have this huge army of memory cells which go directly and prevent this microbe from causing an infection. So in the end, you don't feel ill at all because the response is so strong and so efficient. Yeah, so I think this was my part of the talk. Now Heather will talk about some controversies which you might have heard from the news and some common questions about vaccines. So.
Thank you, Rakina, for that great introduction to the cells of the immune system and what vaccines are. And as Rakina mentioned, we're going to switch gears now and discuss really why we're all here tonight. This series is called Science in the News, so I'm going to first talk about vaccines in the news and then move on to some common questions about vaccination. So 20 to 30 years ago, vaccines in the news, headlines would look something like this. In World Health, magazine cover, smallpox is dead. Front page of many newspapers, vaccine triumphs. These headlines were very positive and very pro-vaccination. These days in the news, unfortunately, we find more often than not we find headlines that look more like this. They are very negative. They can be very anti-vaccination efforts and sometimes downright frightening. So it's important to talk about how vaccines are portrayed in the media and why they're portrayed as such. One of probably the biggest anti-vaccine movements that has started recently or within the last 10 years or so is a link to autism. So first, what is the autism epidemic? So the autism epidemic refers to the unusually high and growing number of autistic kids globally, so around the world today. And so this is just a graph of the number of autism cases that were diagnosed in different years from 1993 to 2006, and you can see this rise in cases. Now, if we take this down, scientists like to use some of these different terminology and convolute data sometimes. So this is per 10,000 children. So 4 in 10,000 children is actually a frequency of 0.04, whereas in 2006, above 40 would be 0.4% of children in 2006 were diagnosed with autism. So you can see this is a tenfold increase in the number of cases of autism in this year. But how did this get linked to vaccines? And that started in 1998 by one individual publication that was published by a man named Andrew Wakefield in a British journal called The Lancet. This paper reported on 8 children who developed autism and some intestinal problems after they received their MMR, so the trivalent measles, mumps, rubella vaccine. And in this study, there was a total of 12 children, and 8 children developed autism. Now, at first, this paper, when it was first published, it was sort of unassuming. So even The Lancet knew that the study was rather small, only 12 children, and so it denoted it already as an early report. And when it first came out, a lot of people thought, well, this was a stepping stone to be either proven or disproven with many more studies. Unfortunately, this one paper led to a complete media storm where the media, including some celebrities, particularly a few with autistic children, completely sensationalized the results of this report. And this was really the start of how autism had essentially a bad influence on vaccination rates. So But we're not here to, necessarily blame the media or blame Andrew Wakefield.